Hi, welcome to this first video on Unit 2.1 exponential functions. In this video we're going to be looking at the first stuff on indices and index laws. The syllabus uses the words review, so hopefully you've seen a lot of these index laws before. I'm not going to go through them in great detail, I'm just going to do a few examples. So the first part of the syllabus here is we're going to review indices, including fractional and negative indices and the index laws. Use radicals and convert to and from fractional indices. So what it means by radicals is just that. So we'd say the square root sign, we'd sometimes call it a surd. Here it's saying that it's a radical. So converting in between the square root of 2 and what that actually means, which is 2 to the power of a half. And for another video we're going to look at understanding and using scientific notation and significant figures. So the first few videos just going to go through indices and the index laws. So these laws should be really familiar. When we're multiplying two numbers or two algebraic terms and the bases are the same, we can add the powers. When we're dividing, we subtract the powers. And there's some examples there, you can see how that works with the cancelling. You should also know that if we use that rule for dividing, then a to the power of 0 will be the same as 1. And the negative index law here. So just look at this quick example I've written down. X squared over x to the 4. If you use the index laws, that's 2 minus 4, or x to the power of negative 2. That's one way that you could write it. Or you could know that that's 2 x's on the top, 4 on the bottom, 2 cancel, leaving with x squared on the bottom line. So it's also 1 over x squared. So clearly those two things are equivalent. So that leads to this law here, which is the law for negative indices and how we deal with those. So if I have 3 to the power of negative 4, I can write that as 1 over 3 to the positive 4. If I have 1 over 2y squared, I could write that as y to the negative 2 over 2. Notice in this case here that the number hasn't moved. That squared there only applies to the y, not to the 2. So the 2 stays where it is. The y to the positive 2 on the bottom comes to the top and becomes y to the negative 2. Here's some examples. Evaluate each of the following without the use of a calculator. So 8 to the 19 over 8 to the 17. Subtract the indices. 8 squared is 64. 3 to the 0 is 1. 2 times 5 to the 0 is 2 times 1, so we get 1 plus 2, which is 3. 2 to the power of 8 divided by 8. 2 to the 8 is 2 cubed, so if you write this all in powers of 2, then we subtract the powers, 2 to the power of 5, which is 32. And lastly, 6 to the 3 times 6 to the 7 over 6 to the 8. You could do the top line first, so 6 to the 3 times 6 to the 7 gives you 6 to the 10, divided by 6 to the 8, subtract the powers, gives you 6 squared, or 36. Okay, so 5 to the 8 divided by 5 to the 5 is 5 cubed, and this one it just wants us to leave it as a power of 5. 5 to the 7 times 5 to the 25 is 5 to the 7 times 5 squared. Add the powers gives us 5 to the 9. 1 over 5 to the 4, putting that all of that up to the top line, changes it to 5 to the power of negative 4. And 0.2, which is the hardest one here, 0.2, if you recognise that as 1/5, and 1 over 5 is putting the 5 to the top line, 5 to the power of negative 1. Because really, that's 1 over 5 to the 1 there, so the answer is 5 to the power of negative 1. The last rule here is a law for fractional indices, and it all comes from this simple observation that if you multiply a to the half times a to the half, you get a, because you're adding the powers. So you've got two numbers times together to give you a. That's got to be the square root. Square root of a times the square root of a is equal to a. So extending that now, we can do that for power of a third. I've got b to the power of a third, b to the power of a third, b to the power of a third. Add the indices, gives you b to the power of 1. So b to the power of a third has got to be the cube root, right? Because the cube root times a number times itself 3 times to give you b. That must be the cube root. So that leads to this law here. A to the power of 1 over n is the nth root of a. So that defines what we mean when we say 16 to the power of a quarter. That means the fourth root of 16. And taking that one step further on here, if we have a to the m over n as a fraction. So we know that we could write it like this, a to the 1 over n to the power of m. Remember the index law that says when we have a power to a power, we multiply the powers here. So that will work. So a to the 1 over n is the nth root of a to the power of m. And it doesn't matter which order you were to do those in. So if you go a to the power of m and then the nth root, it wouldn't matter which order you did those in. So for example, if I have 8 to the 4 over 3, that is the cube root of 8 to the power of 4. Of course, when you're doing these on a calculator, you don't know what 8 to the power of 4 is, so it's much easier to do the cube root first. Cube root of 8 is 2. 2 to the power of 4 is 16. So that's what we mean by a fractional indice there. Let's look at this example now where we've got some fractional powers going on. So 16 to the power of a half, or 0.5, is the same as 16 to the power of a half, which we know is the square root of 16, which is 4. So all this is going to be done without your calculator. In part B, simplify inside the brackets first, 2 to the 6 over 2 to the 4. Remember, base is the same, subtract the powers. That's 2 squared squared. And we know the rule now that when we've got a power to a power, we multiply the powers. That's 2 to the power of 4, or 16. 3 3/8 to the power of a third. Now we're getting a bit tricky. 3 3/8. If you get a fraction like this, it's a mixed number, make it into an improper fraction. So that is 8 times 3, 24, plus 3, 27 over 8 to the power of a third. Now power of a third means cube root. So now I can just cube root the top line. Cube root of 27 is 3. Cube root of the bottom line, cube root of 8 is 2. So that's just 3 over 2. And you can leave it like that as a fraction. 8 to the power of 4 over 3. Okay. So let's use what we know about fractional indices. The bottom line here, 8 to the power of a third, is cube root. So we could write it like this, 8 to the power of a third to the power of 4. And so I know that this is the cube root of 8 raised to the power of 4. So the cube root of 8 is 2, and the answer to that one is 16. Okay, let's look at example 4. We're going to put them all together now. These are the kind of questions that you might get in the exam. So in part A, 5 times 6, so we can just deal with the numbers separately. So that's going to be 30. And deal with the powers separately. So a squared times a to the 4, add the powers. Y cubed times y to the 7, add the powers, giving us y to the power of 10. Okay, in B we're dividing. So 25 over 15, we can simplify the fractions there. 5 goes into 25, 5 times. 5 goes into 15 3 times. So we can simplify the numbers like that. A divided by a to the 7. What I would do is subtract the powers. You could write that either as a to the negative 6 on the top. 1 minus 7 is negative 6. But the question's asking for our answers in terms of positive indices. So what I'm going to do is, rather than writing a to the negative 6 on the top, I'm going to write a to the positive 6 on the bottom. Okay? And then we've got b to the 9 over b to the 4. Subtract the powers. 9 minus 4 is 5. We get b to the power of 5 on the top. And that's as simple as we can get it. C. I would first deal with the brackets. So a to the negative 7 times a to the 3. Add the powers. Negative 7 plus 3 is negative 4. Now, we know the rule that says when we've got a power to a power, we multiply those numbers. So negative 4 times a half is negative 2. And a to the negative 2 we can write as 1 over a squared, using our law for negative indices. And finally D. There's a number of ways you can approach D. I'm going to do 2 different ways. Let's recognise that when we've got a power out the front here for this one, that we want to do the top line and the bottom line to that power. And we want to do each individual term to that power as well. We're all multiplied here. There's no pluses going on here that would confuse things. So this just means that we've got to do -2 to everything here. So a cubed to the -2, power to a power, multiply a to the -6. B to the power of -2 is just b to the power of -2. And on the bottom line, b cubed to the -2 is b to the -6. Okay, so we've got rid of that -2 out the front now. So on the top line, we're left with a to the power of -6. Let's just leave that there for now. The b's, that's nasty. You could subtract the powers, right? Let's think of it that way. -2 subtract -6 is -2 plus 6, which is 4. So we've got b to the power of 4 on the top line. A to the power of -6 on the top line will become a to the power of +6 on the bottom line. So there's my final answer, b to the power of 4 over a to the power of 6. Now here's another way of doing it. If you've got a fraction, let's say 2 over 5, and we say to the power of -1, one way that we can think of that is that's 1 over 2/5 to the +1. Now 1 divided by 2/5 is the same as 1 times 5 over 2. When we're dividing, we multiply by the reciprocal. So this is just going to be 5 over 2. Okay, so that suggests, if we look at these two here, that a way to deal with negative indices when you've got a fraction is just to flip the fraction upside down. And that works even if we say like 2/3 to the power of -2. I could just straight away say that's 3 over 2 to the power of +2. So flip the fraction around and that will change that sign. Doing it the long way, 1 over 2/3 squared. So that is 1 divided by 2/3 squared, so that's 1 times 3 over 2 squared. So it's easier to think of it that way. So for this question here, what I could have done at the start, a cubed b over b cubed, the power of -2, is I could have just dealt with the b fractions first and said that this was a cubed, b over b cubed is b squared to the -2, and then I could have just flipped it upside down and said that's b squared over a cubed to the power of +2. Okay, so I've done the reciprocal of the fraction, and then that changes that sign of the power, just whether it's positive or negative. So this is b to the power of 4 over a to the power of 6, which is the same answer that we got here before.